Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in exercise 12.1 ninth sum. So here we can see the given linear programming problem. We need to solve it graphically. Okay. So ninth one, maximize z equal to minus x plus 2y subject to the constraints. And you can see 1, 2, 3, 4. 4 inequalities we have. Okay. So we need to find the maximum value of the z. First, I will tell you what actually we need to do, then we can move on with the solution part. So, using the given inequalities, okay, so using the given inequalities, we have to find out feasible region. Feasible region is for all the five inequality, the common solution space should be there. Okay, common solution space should be there. In case if there is no feasible region, that is common solution space is not there, then no solution for the given z. Okay, no maximum, no minimum, nothing, it's a no solution at all. So if it is feasible region is there, then you need to check whether it is bounded or unbounded. Bounded or unbounded. Okay, the bounded meaning is the feasible region if it is a closed figure, it will be like a some polygon. Okay, then it is bounded. If it is a open figure, then it is unbounded. Okay, the common solution space, if it looks like a open figure, then it is unbounded. If it is like a closed figure, like a polygon, then it is a bounded. Okay, so whether it is a bounded or unbounded, we need to check the corner points. Okay, we have to find the corner points of it. After finding the corner points in the given z, okay, so whatever z we have, substitute the corner points, you will get some results. Okay, some values you will get. So out of those values, the largest one will be the maximum value. Okay, the largest one will be the maximum. That's all the solution. In case if it is unbounded, then you have to find out the corner points. Same, the corner points you have to substitute in the z. Okay, so normally how you will find the biggest value after substituting all the corner points, out of all the results, the biggest value will be the maximum, right? So maximum you will identify. The same way here also you will identify, but since it's unbounded, the maximum value will be may or may not. Suppose you are getting z as some 200, for example 200 you are getting, comparing the other is 200 only the biggest value, then 200 may or may not be the maximum value. To confirm it, what you have to do is, with the help of the given z, you have to frame a new inequality. Okay, so what is the given z? Minus x plus 2y, right? So what is the question about maximize? Maximize means use the greater symbol, then 200, whatever value you are getting, that you have to use it. Then in the same graph, okay, in the same graph you have to find the solution space for the minus x plus 2y. Okay, then if it is the feasible region and the solution space of this particular inequality, if the common points are available, if there is no common point means, then yes, 200 is the maximum. In case if the common points exist, then 200 is not a maximum, that means no maximum value of it. So you understand the process. So if it is unbounded, with the help of the maximum value, whatever we are getting with the help of corner points, frame a new inequality. After forming the new inequality, just check the solution space of it. Then feasible region and the new inequality should not have any common point. If one common point if exist also, then 200 is not maximum. In case if there is no common point between feasible region and minus x plus whatever you are forming the new inequality, if there is no common point, no common space, then 200 is the maximum value. So we can confirm it. Okay, so this is the process. Let's start doing the solution part now. What is the first inequality that we can see? X greater than or equal to 3. So that means the inequality we have to consider as the equation x equal to 3. So now that x equal to 3, we have to plot it in a graph. We know that all linear programming problem is in the first quadrant, so giving more space for the first quadrant now. Okay, I think I'm giving a very little space, same space, sorry, 2, 3, 4, 5, 6, 7, 8. I think till this is enough. Okay, what is the first one we got? X equal to 3. X equal to, see, this particularly y-axis is x equal to 0 line. Now x equal to 3 here we have, right? So this particular line is the x equal to 3 line. Yeah, this particular red line is what? X equal to 3 line. Now we need to identify the solution whether we have right side or left side. Okay, what is the given inequality? X greater than or equal to 3, right? Whether the solution space for the x greater than or equal to 3, whether we have a right side or left side, we have to identify. Only right side you can see greater values, right? That means first quadrant, okay, first quadrant and fourth quadrant is the solution for the first inequality after this. So this right side we have. Okay, so this is the solution space including the line, and the shaded part is the first inequality's solution space. Now what is the second one that we have? X plus y greater than or equal to 5. Now we need to identify solution space here. For that, the given inequality we have to change it as a equation now. Okay, I'll do it over here. So let, what is the second inequality? X plus y greater than or equal to 5. No, so x plus y equal to 5. Now we need 2 points. Okay, minimum 2 points to draw the line of x plus y equal to 5. If x equal to 0, y value will be 5. If y equal to 0, substituting here x, you will get it as a 5. Now 0 comma 5, 5 comma 0, let's plot it here. So here we have 0 comma 5 and 5 comma 0. Now connecting these two, yes, so we are getting the line of x plus y equal to 5. Okay, x plus y equal to 5. Now we need to identify the solution space. So after drawing this yellow line, the graph is dividing into two portions. One is upper side and here the lower side. Okay, so which side we have a solution that we have to identify. Let me take randomly any value which lies this side, 0 comma 0, let's take. Okay, and substituting 0 comma 0 in the second inequality, no, if x value is 0, y value 0, 0 plus 0 is what? 0. What is the condition that is given? Greater than or equal to 5. No, is it true? Is this condition satisfying? No, condition is fails. That means we can say for the second inequality we don't have a solution this side, then obviously the other side only we will have. So we will have solution the other side, this side we will have. Okay, now next inequality is x plus 2y greater than or equal to 6. So now third inequality, we have to take the, to identify the solution for this, first we need to convert the given inequality as a equation. X plus 2y equal to 6. If x equal to 0, okay, if x equal to 0, then corresponding y value, 2y equal to 6, 2 ones are 2 3s are, y will be 3. If y equal to 0, x takes the value 6. Now 0 comma 3, 6 comma 0. So here 0 comma 3, 6 comma 0 here. Now connecting these two blue lines, no, we can able to get, sorry, we can able to get the line of x plus 2y equal to 6. This is the x plus 2y equal to 6 line. Now after drawing this blue line, no, the graph is dividing into two parts. So again upper and lower, which side we have a solution we have to identify. So again I'll take the least values, whether this side, if obviously if this side solution is not there, then obviously the other side only will have a solution. So 0 comma 0 I am going to check, substituting 0 in place of x and y. Then 0 plus 2 times of 0, which is 0, which is 0 again, right? Then is it 0 greater than or equal to 6? Is that condition is true? No, this is false, right? Then obviously the solution we don't have this side. For the blue line, we don't have solution the lower side. So we have a solution the above upper side only we have. So shading now upper side. Okay, I just shaded for the solution space for the third inequality. Now finally what we have, y greater than or equal to 0. Y greater than or equal to 0 means where, what is the y equal to 0 line? X axis only y equal to 0 line. Y greater than or equal to 0 means first quadrant and second quadrant. Okay, first quadrant and second quadrant only, y greater than or equal to 0. Okay, that means this side we have. Now for all the four inequalities, what is the common solution that we can identify? Are we able to identify the common solution? See, this is the y equal to 0 line. Okay, this is the y equal to 0 line. Y equal to y greater than or equal to 0 means it starts from here, this way. Okay, so this first quadrant and second quadrant. Now you can notice that all four inequalities, 1, 2, 3, 4, for all the four inequalities, what is the common solution space that you can see? I'll just remove this one, triple shaded one. You can notice, no? So for all the four inequalities, you can notice that starting from here. Okay, so starting from here, this line, no, basically I'll draw the line also. So starting from here, then this side below we don't have. Okay, then going on this way, and there is a one corner point here. Okay, now this way, then straight, no, only the first quadrant we will have, right? Then all the entire portion, so I'll just shade it now. This complete entire portion, no, will be the feasible region. Feasible region is available because for all the four inequalities, common solution space is there. But whether it's a bounded, is it a closed figure are we getting? See the shaded one fully, it's a feasible region. But do you see it's bounded? It's not a bounded, no. If it is not a bounded, then it is unbounded. Yes. Okay. So we'll write the same now. First we have to identify the corner points now. Wherever two lines meets, okay, in the feasible region, totally how many equations we have? X equal to 3, x plus y equal to 5, x plus 2y equal to 6, other one y equal to 0. So in the feasible region, wherever the two lines meets, no, that will be the corner points. So you can see here there is a yellow line and x equal to 3 line is meeting up, right? So then this will be one of the corner point. So what is a corner point? Just see. So 3 and 2. Okay, 3 comma 2 is the one corner point. This is the one of the corner point. Okay, another corner there is a bend you can see, and this is the common meeting point of yellow line and blue line. So this will be the other corner point, and the coordinate point if you see 4 and 1, so 4 comma 1 will be the other corner point. And the next corner point, just follow the white line, no, just follow the white line, and you can see y equal to 0 line and blue line. That blue line both are meeting up here. Then 6 comma 0 will be the other corner point. So totally three corner points we have. Okay, and we'll write the same. The feasible region exists. Feasible region. Feasible region exists, and it is unbounded. And it is unbounded. We are not getting a closed polygon here, so it's unbounded. And corner points are what are the corner points we have? 3 comma 2, 4 comma 1, 6 comma 0. Only three corner points. Now these three corner points we are going to substitute in the given Z. Corner points and Z equal to minus x plus 2y, minus x plus 2y. First point 3 comma 2, 3 comma 2, and second one 4 comma 1, third one 6 comma 0. Now substituting 3 comma 2, minus 3 plus 2 times of 2 equal to minus 3 plus 4, which is 1. Okay, next 4 comma 1, 4 and 1, if you substitute, minus 4 plus 2 times of 1, which is minus 4 plus 2, which is minus 2. Next 6 comma 0, minus 6 plus 2 times of 0, then result is 6, sorry, minus 6. Okay, now uh, what is the question given? Maximize the z, right? That means out of these three results, what is the maximum value that you can see? These two are negative. Okay, only one positive value you have, so one will be the maximum. Okay, one is the maximum, but whether it's a bounded, since it's unbounded, one may or may not. So if it is a bounded, that's all the solution, one is the maximum. Since it's so unbounded, since it is unbounded, one is may or may not be the maximum. Now 50-50 chances to confirm, no, whether it's a 1 is a 100% is maximum or not. We need to do one more, we need to consider one more inequality. Okay, we have to frame a one more inequality with the help of z. What is the given? Z minus x plus 2y, right? Since they are asking for the maximum, okay, so minus x plus 2y, so we have to form a new inequality, minus x plus 2y. Maximum they said, so maximum is greater than symbol. What is the maximum value that you got? 1. Now we have to identify the solution space for this. To identify the solution, I'm going to consider the this inequality, no, this inequality as a equation, minus x plus 2y equal to 1. To draw the line of minus x plus 2y equal to 1, minimum 2 points are required. If x is 0, no, then 2y equal to 1, y equal to what? 1 by 2. We are getting y as a 1 by 2. Y is 0. Okay, minus x equal to 1, then minus 1. So now let's plot these points, 0 comma 1 by 2, which is 0 0.5. So 0 comma 0 0.5, 0 comma 0 comma 0 0.5, somewhere here it lies. Okay, 0 between 0 and 1, 0 comma 0 0.5. The other one is minus 1 comma 0. X as a minus 1 comma 0. So where we will have minus 1 comma 0 somewhere, let it take this as a minus 1, minus 1 comma 0. So using a scale we can draw the line and we can extend to get the line of that. Otherwise what we can do, we can take one more value, which is larger value. I'll take x as a, sorry, y as a some 6 I will take. Okay, if y as a 6, now minus x plus 2 times of 6 equal to 1. Okay, now solving this, minus x plus 2 6 are 12 equal to 1, minus x equal to 12. If you take it to the other side, minus 12, then minus 11. So x will be what? Positive 11. So 11 comma 6, let's consider 11 comma 6. Somewhere this point will be 11. 11 comma 6 somewhere here. This point is 11 comma 6 point. Now let's connect all the points. Try to connect it. Okay. Mm. Okay, now after drawing this white line, no. Okay, after drawing this line, this graph is dividing into two portions. One is above and below. So we need to identify where we have a solution for this. Randomly, let's take some value. Okay, any value in lower part or upper part, any value is fine. So let me take 0 comma 2. Okay, 0 comma 2, let's substitute here 0 comma 2. So minus 0 plus 2 times of 2. What is the value that we are getting? 4. No, 4 is greater than 1 only. Condition is satisfying. That means we have a solution. Upper portion, upper side we have. Okay. So this side we have. I'll draw it in a white itself. So we have a solution this side now. For the new inequalities, where we have a solution this side. Now you tell me, for the feasible region and for the new inequality which we framed, is there any common point? Yes, we can see the common solution space, feasible region, and for this you can see something is in common, right? So you can write the same. The feasible region has a common solution space, common points for the minus x plus 2y greater than 1. So we can say that the feasible region has a common points with minus x plus 2y greater than 1. Now tell me, if there is a common point exists, no, then is that a maximum? No, it's not a maximum now. So 1 is may or may not be said, right? So 1, therefore 1 is not a maximum. That means what we can conclude? There's a one hope only we had, that is 1, right? That also is not a maximum. That means no maximum value for the z. No maximum value for the z. Okay, so that's all the solution. Thank you for watching and please do subscribe. Thank you.